Good afternoon. Today we're going to talk about vertical asymptotes as the first time we finished horizontal asymptotes. I'm going to have a separate video to share with you the key for finding horizontal asymptotes, but this one is specifically to find the vertical ones. And just a quick reminder, an asymptote is a line that the graph approaches to without touching. I had a little screenshot of everything we had in 1.2 notes, but a little bit smaller so I can use them here on my whiteboard. And we're going to start again by just a refresher. So an asymptote is a line that the graph approaches to without touching it. The vertical asymptote is a line. And how do we find that? We're going to look at the given function, and I'm going to rewrite it. If you guys remember the parent reciprocal 1 over x, and you should also remember the graph of a parent reciprocal, we said there is a cut at 0, or what we called discontinuity in fancy words. Easy words, cut at 0. And why is it 0 specifically again? Because it comes from the fact that we can't have the denominator equal to 0. So this value is not allowed. We need to exclude it, and this is why this cut happened. Similarly, when we need to find a vertical asymptote, this is the process. We're going to take the denominator, we're going to equal it to 0. And the reason why we want to equal it to 0 because we want to find the not allowed values, those values that create a problem. As you notice right here, an advantage is my denominator is in a factored form. So all what I gotta do, I'm gonna take x plus 2, equal it to 0, x equals negative 2, and I'm gonna take x minus 5, equal it to 0, and x is gonna equal 5. So I know ahead when I graph this function, there's gonna be two cuts, two vertical asymptotes at negative 2 and at 5. So I would say, and I'm going to use this abbreviation, there are two vertical asymptotes. Now, with vertical asymptotes, it's not as easy as horizontal asymptotes because you still need to check the values. By definition, a vertical asymptote occurs at any value for which the denominator equal to 0, but the numerator is not equal to 0. So guess what happens if I plug negative 2? If I plug negative 2, I will have also the numerator equal to 0. So this is not a vertical asymptote, and we're going to call it a hole in the graph. And I'm going to show you that in a minute with the next example. I'm going to show you how on the graph you're going to get a hole. So this function has one vertical asymptote and has one hole at negative 2. So let's repeat that. Take the denominator, equal it to 0, find the not allowed values. The values that make the denominator equal to 0, those are the vertical asymptotes. And the ones that make denominator equal to 0 and also the numerator equal to 0, those will also be holes. Those will form the holes. So if we go back to this example, it says name the vertical asymptotes. For number 1, I'll look at the denominator. I'll equal it to 0. Nicely in factored form. So all what I gotta do, I know that x is 3, x negative 3, x negative 4. Those are the zeros of the denominator. And I look at those. If I plug them in the numerator, only this last one makes the numerator also equal to 0. So I know the last one is a hole, and those two are vertical asymptotes. Now I'm going to switch to my Desmos screen. I graphed this function. And we're going to see how on the graph this will show. So x equals 3 is the vertical asymptote. Look how the graph is approaching to it, but not touching. X equals negative 3 is another vertical asymptote. And if you guys remember from my previous screen, at negative 4, there's going to be a hole. Now, on decimals, it's a little bit tricky, but you keep moving and look what it says at negative 4. It has an undefined y value, and if you look closely, I can't let go because it won't show me the point anymore, but if you look closely, you will see an open circle at negative 4, which determines a hole in the graph. There's no output. The output is undefined, but it did not create a line. It created just a hole. Did not create an asymptote. A full cut was a small discontinuity, if you want to think about it that way. So now it's your turn to apply this concept, and you're going to do examples or page 95, 55 through 62. The first time you did it by finding the horizontal asymptote, now you're going to try to find vertical asymptote. And I want you to keep in mind that if your denominator is not factored nicely, that means you have to factor the denominator first. And one last tip, as you notice right here in our first example, you can see x plus 2 on both numerator and denominator, which explains why we got negative 2 a whole. Again, in number 1 that we just did, you see x plus 4, which created the whole. The other two values only exist on the denominator, which makes it a vertical asymptote. So this is the little trick, but that's only if you have your numerator and denominator in factored form. So keep in mind, when you want to find your vertical asymptote, you take your denominator equal to 0, and you're going to factor numerator and denominator if needed. So you're going to factor numerator and denominator if needed. And this is all for today. Again, you're going to be working on page 95, 55 through 62.